Hello everyone. In today's video, you will learn how to construct and test 4-bit SIPO serial input parallel output register. At the end of this video, you will be able to construct and test 4-bit SIPO serial input parallel output register using IC74LS95. Let us collect all the tools, equipment and materials required to do this practical. Digital trainer kit with user manual, IC74LS95 with data sheet, male-to-male jumper wires, magnifying lens. Let us discuss on SIPO, serial input and parallel output in shift registers. SIPO stands for serial in, parallel out, and it refers to a type of shift register in digital electronics. In a SIPO shift register, data is inputted serially one bit at a time and then shifted out in parallel all bits at once. Serial in. This indicates that the data is entered bit by bit in a serial fashion. Each bit is entered sequentially, usually on each clock pulse. Parallel out. This indicates that the data is available simultaneously at multiple outputs in parallel. The serial data example binary sequence 1010 is applied to the serial in input. On each clock pulse, the serial data is shifted into the first flip-flop D0, then into second D1, and so on. After 4 clock pulses, the entire serial data 1010 is loaded into the shift register. The parallel outputs Q0, Q1, Q2, Q3 represent the state of each flip-flop after the shifting process. In this example, the clock pulses triggers the shifting of the serial data, and after 4 clock pulses, the parallel output represent the binary sequence 1010. Each flip-flop stores 1 bit of the serial data. Let us discuss about the available 14-pin dual inline package IC74LS95. The IC74LS95 is a 4-bit parallel access shift register with parallel load capability. Pin 7 and 14 of IC74LS95 are allotted to ground negative and plus 5 volt power supply. Pin 1 is serial data input. Pin 2, 3, 4 and 5 are 4-bit parallel inputs. A, B, C and D respectively. Pins 13, 12, 11 and 10 are 4-bit parallel outputs. QA, QB, QC and QD respectively. Pin 6 is the mode selector with mode control input at logic inputs A is equal to, B is equal to, C is equal to, D is equal to 0. Result in QA, QB, QC and QD equal to 0, 0, 0, 0. Pins 8 and 9 for left and right shifts respectively. Construction and testing of 4-bit serial in, parallel out. Collect all the components, check them and assemble the circuit as a serial in, parallel out SIPO shift register. Identify the IC74LS95 printed on the top of IC using a magnifying lens. Identify the pin number 1 of the IC and align it in the right position. Gently insert both the lines of pins of the IC into the breadboard in the digital trainer kit. Connect the pin 7 to ground and pin 14 to plus 5 volt supply using jumper wires. Connect the pin number 9 to the clock input in the digital trainer kit. Identify the output LEDs as QA, QB, QC, QD in the digital trainer kit. Connect pin 13 to the output LED QA. Connect pin 12 to the output LED QB. Connect pin 11 to the output LED QC. Connect pin 10 to the output LED QD in the trainer kit. Connect the mode selector pin 6 to the input toggle switch in the digital trainer kit. Connect pins 2, 3, 4 and 5 to toggle switches A, B, C and D respectively. Connect pin 1 to input toggle switch for serial input. Switch on the power supply. Apply logic 1 to mode control input and apply clock pulse and record the parallel output logic levels QA, QB, QC and QD should be 0, 0, 0, 0. Set logic 0 to mode control input and set logic 1 to serial input. Apply a clock pulse to the clock input and observe the LEDs connected to the output QA, QB, QC and QD. Serial input 1, clock pulse 1, output 1, 0, 0, 0. Serial input 1, clock pulse 2, output 1, 1, 0, 0. Serial input 1, clock pulse 3, output 1, 1, 1, 0. Serial input 1, clock pulse 4, output 1, 1, 1, 1. Now apply logic 0 to serial input and apply a clock pulse to the clock input and observe the LEDs connected to the outputs QA, QB, QC and QD. Serial input 0, clock pulse 1, output 0, 1, 1, 1. Serial input 0, clock pulse 2, output 0, 0, 1, 1. Serial input 0, clock pulse 3, output 0, 0, 0, 1. Serial input 0, clock pulse 4, output 0, 0, 0, 0. Thus, we have constructed the 4-bit SIPO register using IC74LS95, tested and verified with its truth table. Hope now you will be able to construct and serial input parallel output test 4-bit SIPO register using IC74LS95. This concludes the session on how to construct and test 4-bit SIPO serial input parallel output register. Thank you.